Yeah, time has come to have some attention to the ML7 bearings. I have an ML7 headstock here, and I have the caps that should go on like this with the bearings inside. Front bearing and rear bearing. These are of course then split half bearings. They are white metal, and as you can see they are quite worn. This example was quite worn. I have 3 headstocks to do, and the way I'm going to do it is by scraping. I'm going to fit the halves into the headstock. At least that's my method. I know I've experimented a little bit back and forth, but prove it to be the most economic and the easiest, comfortable way to do it. So I'll test the bearings like this in situ. Just, of course, snug them in place. And used to be from the start originally fitted shims like this, and to compensate for the wear, of course, you remove the shims or peel off a part of the shim, and made up of layer or laminations, so you can peel off different thicknesses to accommodate for wear. But I want to also scrape them in. The test method I will use is to use one example of a shaft, a spindle, and then put in here and then glue it up. And the way I'm gluing up the spindle is to charge from here, then just put on the minimum amount to be able to see the blue spots. And of course you will, when you use the finger like this, it will be you'll be able to verify that there is no grit nor any particles left there or inside. And do the same for the front. And I have the spindle set up securely in the vise. So the way I do this, I put the newly blued spindle directly on top. I will do the top afterwards, and this should be just lightly coated with blue. A little bit back this way, axially and radially, is enough to glue up. I do it, let's say, one step at a time. So I test the lower parts in this, and then I replace them with the upper part. I do them, and then I close it together so I get a total reading. So then it's just a matter of scraping the blue spots as we have them here, interpreting the highest spots and getting a good coverage or percentage of points, POP, and then establishing the PPI, the number of points, just as you would do on a flat bearing. As you can see, there is only small spots, and it's primarily to the lower part, so I'll have to work on that. The way I'm doing that is using spoon scrapers, whatever you have or have made. These are, I think, this is at least not shop made. I can imagine this is probably made also professionally, but it comes from a professional shop at least. And now what I do, I scoop out. These are called spoon scrapers. So I scoop out, not applying much pressure really, because this white metal bearing is very soft. So starting from the front, and then I try to go up this way, and then a little bit forward, and the same up there, a little bit forward. For deburring, I'm using well, a knife tool, you can say, but it doesn't bend, so I just carefully deburring like this. It's a very soft material, so I don't want to take off too much, or so a little excessive blue just to get the feeling of well, the depth of cut and such. I tend to use this spoon scraper better, so I rest it down and then I just swoop it while I go forward. I charge it with a little bit more blue, and then you can see much better, really. Finishing stages I might not use that much blue. And I'm doing this really to use up or to reuse the old bearings, but there is also a possibility to buy new bearings. Then you buy a new shaft also, because you use bronze bearings and a hardened shaft as a kit, and they also will need to be scraped in. So okay, it's creeping a little bit up on each side. I can see I have some high spots. I'll take them out first, and those are distinguished by the same as you have on normal scraping, namely, and this is the front bearing after some iteration, some scrapes. And I want just to point out, for instance, this guy over here. You can see it's shiny in the middle and have the blue ring surround, which means probably at least that this is the highest. This is higher. For instance, this over here. This is also quite high. So you can, these are normal, at least in comparison. So you can try to distinguish which ones are highest. The rear bearing over here, you have the same. This guy is rather high compared to this doing with this mark. So this needs to go first in comparison with this. Same with these over here. So I'll just take out those that I have seen now are the highest and redo the bluing, and then I'll show you. So taking out just those few. Same here, just a few. Leaving the others. Maybe one more there. This guy. And you see, now I'm beginning to get somewhere. Bigger blotches, those can be cut up later on. At least I'm getting more and more coverage in my eyes. After some more scrapes, I can see it's climbing a little bit onto the sides, so I'm satisfied with that. And then I have to work on, of course, the percentage of points here. Let's say the coverage. and also the PPI afterwards, but at least the POP, the percentage of points, which means how much of the area is covered with points, and that they are equally spread out. Somewhere. I like a little bit of coverage over here, and a little bit in front here. I took a little bit more blue so that I can more vividly see where it is not hitting, and even now more now is covering here. You see it's still not here, and not on this side, so then I know that this is really low on the sides there. Yeah, I'm looking at quite even pattern over here, or at least coverage, but I took off a little bit too much back here. Let's do a test like it was a flat bearing. Rotate a little bit, and then, I mean, the spindle is round anyway, so you don't necessarily need to rotate all the way around. Just get a good test. And it's starting to be a little bit more consistent. Still one more go. So I'm starting to get a good pattern now. I'm seeing a little bit up here that lacks, and a little bit too dense down there. And this one is quite okay, actually. At least a little bit up here. So picking the points here now.